Hey, I'm Rob and welcome to my lab. In this video, I'm going to do a hands-on walkthrough showing how to set up Open WebUI on a DGX Spark to interact with a local version of OpenAI's GPT-OSS-20B, which is an OpenAI open weight model with 20 billion parameters. Most of the configuration in this video can be done on a wide range of hardware, but in the recording, I'll be running this on an NVIDIA DGX Spark, which is a desktop Blackwell system. If you want to learn more about the DGX Spark, check the description for a link to a previous video where I introduced it. So here's a quick overview of the configuration. The GPT-OSS model will be served on the NVIDIA Spark. The Open WebUI application will also be running on the Spark, but in a Docker container. And I'll access the Open WebUI app and the Spark terminal via the NVIDIA Sync utility, which essentially creates an SSH port mapping between the Spark system and my Mac desktop using a GUI interface. Okay, so let's get into the setup. First, I'll use the NVIDIA Sync to open up a dashboard to monitor the unified memory and GPU utilization on the Spark while we walk through the configuration. So we can see that the memory utilization is pretty low right now. It's about 12.5 gigabytes, which is just being used to run the OS on the Spark. There's no GPU utilization at the moment. So first, I'm going to get the Docker image downloaded and create a Docker container that will run Open WebUI. And to do that, I'll open a terminal. Just to check I'm on the right system, I'll run NVIDIA SMI, and I can see I'm on a system with a single GB10, so that's the Spark. Next, I'll use Docker pull to pull down the Open WebUI with a Llama image, and that takes a while, so I'm going to speed up the video. But then once the image is pulled locally, I can use the Docker run command to create the Open WebUI Docker container. Note that I'm creating the container with a port mapping from port 8080, which is the port Open WebUI runs on the inside of the Docker container, to port 12,000. That's the port I'll connect Open WebUI to my Mac via the SSH tunnel. So I'm creating a few volume mounts here. This allows the Docker container to use folders on the DGX Spark for long-term data storage. And I'm giving the container a Docker name of Open-WebUI. Okay, so I'll use Docker PS to confirm that the container was created and it's up, but I'm going to stop the container because I'll use NVIDIA Sync from my Mac to start and stop it when I want to use it. So let's get that done now. Returning to the Mac UI, I'll open the NVIDIA Sync UI and add a new custom app for Open WebUI. And in this form, I'll give the custom app entry a name, enter the port I configured the Docker container to listen on, which is port 12,000. I'll take this little box that will have it open a web browser to that port whenever I start Open WebUI from NVIDIA Sync. And then finally, I'll paste in a bash launch script. That script will run on the Spark when I tell NVIDIA Sync to start the app. So essentially, click to start the app, and it pushes that script over to the Spark and runs it. Starts the container. That's all it really does. And I'll put a link to the start script in the notes below. So if you want to take a look at it and use it or just study it for how I did this, you can do that. And then finally, I'll click the add button to save the new custom app. Now we'll see the custom app in the NVIDIA Sync menu, and we can just click it to start the container, and it will launch the web browser for us. And just to confirm the app is really running on the Spark, or the container is really running on the Spark, let's repeat that Docker PS command, and we can see the container did launch and is now running on the Spark side. So I'm just going to rearrange my desktop. I'm going to put the DGX dashboard next to the web UI so we can kind of watch the GPU utilization and RAM utilization as we move forward here. So let's kind of get into this app. So this is a brand new Open WebUI app. So we'll have to set an admin account. And if we kind of go up here, we see we don't have any LLMs installed yet. So let's go ahead and download that GPT-OSS-20 billion parameter model. And once that model is installed, we'll ask just a simple question, just kind of get things running. So I'll type, tell me a joke about programmers. Keep an eye on the VRAM and GPU utilization. We'll kind of see the RAM use increase as the model's loaded into memory. And then as the LLM starts to answer the question, we'll see the GPU utilization will spike. And now after the response is delivered, the utilization returns to 0. So with the model loaded in memory, the next question should be faster. So let's ask something more complex. We'll ask the LLM to give us some instructions for how to create and format a Windows partition. The response was faster, and when it's complete, we have what looks like an accurate answer, with the bonus of how to use dispart instead and some troubleshooting advice. So seems pretty good. Okay, that's all I really wanted to go through. So hopefully this is helpful. And again, while I use the DGX Spark, the same setup is basically the same on other systems as long as they have a GPU capable of running some LLM. So give it a try on your system too. I'll see you next time.